Welcome back. In this lesson, we're going to talk about the types of winds there are, the main types of winds. We're going to see that since the Earth is a sphere and it's turning in the same direction at the same speed, and the same amount of sunlight is falling generally on the Earth every single minute, what's going to happen is you can, over time, suspect that certain types of winds will blow. Those all, of course, have names, and we'll look at those in a minute. We're going to see that these winds are caused by several factors at once. You've got the uneven heating of the Earth. You've got the fact that the Earth is a globe, it's a sphere, and that the Earth is turning, and that the Earth is tilted. All of those things factor in at the same time to cause these various winds that we can name. And so we'll look at them together. So, if you were going to have weather, you're going to have water in air. And that air is going to be at different pressures and different temperatures. And so you're going to end up having moving air. When you have moving air, all with water in it, those air masses are going to collide with each other. They're going to switch around each other. They're going to move each other. And those interactions is what we call weather. Sometimes it can be just a nice, pleasant day with a gentle breeze, and sometimes it can be a hurricane or a blizzard. And all of these conditions basically arise from the heat of the ground, from the sun, and the amount of moisture in the air in different places of the Earth. And, believe it or not, that the Earth is round and that it's moving. So all kinds of factors are putting into, and that it's tilted. We're going to see that there's so many things that's involved with whether or not certain things happen or don't happen. So let's do a general lesson today. Let's just look at the types of winds that there are. So I need to show you a picture. This is a really good one. Let's imagine that the equator here at 0 degrees is where most of the intense light of the sun hits. So of the entire Earth, that's where most of the time it's going to have a high percentage of solar radiation hitting it. So it's going to be hot. And if you think of the equator, that is where the hot places on the Earth are, is right along the equator. So that ground is now going to be hot, and it's going to radiate its heat into the air above it. It's going to heat the air above it, and then that air is going to rise. All right, so right there at the 0 mark, you're going to see some little blue circles. So that air goes up into the atmosphere because it's rising. But then once it gets to the edge there, it's cold enough that it's lost its temperature and it wants to move away. Right? So you're going to have winds that blow from the upper atmosphere there. Okay, now why do they blow curvies? What's going to happen is, you remember the high pressure. Which way does the wind blow? The wind blows from high pressure to low. So if that heated air goes up into the atmosphere and crowds, okay, it leaves a low pressure at the surface. That's where I have a red L. I'm also going to have a high pressure at the upper atmosphere where the 0 is. That would be a high pressure. Well, high pressure moves away from high pressure to low pressure. And so that blue air is going to move north of the equator and south of the equator. Okay, and eventually going to get cool enough that they start sinking. When they sink, all of that, so the circle then makes a full turn. As it sinks, you're going to have a high pressure at the surface, at the yellow marks here on this diagram. Okay, at 30 degrees north and south. So it takes about 30 degrees for that air to cool off and then start sinking. Well, if it's sinking, then it's high pressure, and the high moves to the low, okay, because high pressure always blows to low pressure, and you get these circles of current that are going up into the air and then coming back down on the air. Okay, now this is not just on one side of the Earth. These are in bands all the way around the Earth. Okay, so you're going to have at least these 6, maybe more, smaller ones, but these main 6 of turning, cycling air. Okay, now at the moment I've got blue arrows marking where winds are moving. Okay, winds would move from high to low. So if you've got a yellow band of high pressure and that green and that greeny striped band of low pressure, then all of the wind is going to blow towards the low pressure. The high pressure is going to also blow towards the low pressure at 60 degrees north and south. All right? So that's where the winds would blow. The problem is that the Earth is turning. As the Earth turns, it's going to make those winds arc. And so you're going to get curves of air. So you have, it's ridiculously complicated. You've got air going up into the sky, down onto the ground, and then moving sideways in different regions of the Earth. Now, this could be its own lesson, really. The Coriolis Effect is when the Earth is turning, it's going to make it appear that those straight winds are actually curved, okay? So imagine walking across the floor and the whole floor was turning like a big record player. You would be going straight, but if you were to trace your steps on the floor and then stop the floor, you would see that your path is actually curved along that floor. If the whole floor is curved and moving in a curved way, your straight line would be a curve. And so that's what's actually going to happen. You're going to get these curved lines. And the Coriolis effect is that the Earth is a sphere and it's moving. It's turning on its axis. And the winds are going to blow in a curved path. So these curved path winds are named based upon where it is. So the first ones are the polar easterlies. That's going to be at the very top. And then you're going to have the westerly, the prevailing westerlies. And then you're going to have the easterlies at the bottom. So let's look at a second picture. With the Coriolis effect, those straight winds now appear to be moving. Okay, so when you say have an easterly wind, it's blowing from the east. So a polar easterly is blowing from the east down to the southwest. So from the northeast to the southwest in an arc. Okay. The second band of winds, because of these circles of air going up into the sky, is our prevailing westerlies. Now the United States, the middle part of the United States, is underneath the prevailing westerlies. So most of our wind, our weather, comes from the southwest to the northeast. So the southwest corner of your house has more weather damage than any other part of your house. Okay? If you live south of 30 degrees north, then the winds are going to be seemingly to go from the northeast to the southwest. This can be exactly the opposite. So anyone living in Cuba or Venezuela, what's going to happen is that the winds are going to appear to come out of the northeast and blow towards the southwest. Exactly the opposite of us. And then you're going to see the mirror reflected in the south. So you have the polar easterlies, the prevailing westerlies, the southeasterly trades. Now the trade winds are these easterly winds that are blowing to the equator. And they're called trade winds because that is what made the ships fill their sails as the trading boats were trading in the oceans during the Renaissance and afterwards, during the time of the settlers. So they're called trade winds, but essentially they're easterlies again. You have polar easterlies, prevailing westerlies, and then trade winds, and you name them where they're coming from. So northeasterly trades, southeasterly trades. Then the last one is the equator itself, and that's called the Intertropical Convergence zone. And what's happening is both the trade winds are both slamming into each other as it goes to the west. So sometimes you can have, like the picture at the bottom, you can have clouds just along the equator because these winds are shoving them north and south into each other.